Hello guys, welcome back to Maison African Motives. In this platform, we shall be focusing on the integration. That is the one that you're going to focus on in this platform. We've got questions, which is under the integral calculus, having 20 marks, which is from the question paper of November 2016 that you've been working throughout the other questions. So we're not going to waste much time on 5.5, 5.11. We are given in this case to sketch and indicate the area indicated by the graph of y is equal to the square root of x, and x is equal to 3 in the first quadrant. Okay, so take note, you're given an indication that this must be in the first quadrant. Okay, so let's take a closer look for the graph of y is equal to the square root of x. So you're supposed to know this, guys, from your sketching of graphs from your mathematics. N3, you've been sketching these graphs. So that part, they expect you to have an idea of how this graph actually looks like. So as you can see, if it is a square root of a number, we know that square root of any number is actually a plus or minus. So if you find square root of a number is plus or minus. So that means for any value of x that we have, the corresponding value of y is going to be the same, but it's going to be another one a plus, another one a minus. Like, for example, let's say our x is 4. That means our y is going to be the square root of 4, which is plus or minus 2. So that is the idea of how this diagram is going to look like. If your x is 9, like let's take, for example, 9 is going to be square root of 9, which is a plus or minus 3. So in actual sense, this graph was supposed to be like this. We're supposed to have the sketch of a graph in this format, whereby we've got the values of x in this case, and we've got the values of y, which are corresponding to this information that we had. If x is a certain number, then y is going to be plus or minus. So for any values of x, remember, you can't determine the square root of a negative. Yes, we can have the square root of 0, which is a 0, but we do not have square root of negative values. So we do not have values in this negative region. So our graph in actual sense was supposed to be like this. We've got same values for y in this case, which corresponds to the same values of y taken in this direction. But now take a consideration. We are given a consider to say this must be in the first quadrant. So if it is supposed to be in the first quadrant, that means this part is not going to be there. We are just going to work with the part of the first quadrant alone, which is this part that we have here. So that is what you're going to have at the end, and we're given between this graph and the line of x is equal to 3. So if this is the line, if the graph of y is equal to the square root of x, we know that at x is equal to 0, this point, 2, 3, and so on. So this is where we have our x, which is equivalent to 3. So this is the region that you're going to have in between these graphs. So you can just represent your representative strip to show that you're going to have your area with respect to x. So this is the whole area that we are supposed to calculate, this whole region here. That's where we're going to have our area from 0 to 3. So the question was just for you to sketch this graph. So what is important to show the points, the equation of the line, and so forth, of the curve that you're given. Then on 5.12, we are now given to calculate using integration the value of the area indicated in question 5.11 above. So that part that you indicated, now calculate the area by integration. Okay, so we know that from our integral calculus, we are able to calculate the area from the formula. I've talked about this before, that the area with respect to x is equivalent to the integral of f of x with respect to x, with your limits taken from a to b. So a being the lower limit, b the upper limit, which are the ones that are bounding this graph. So this graph is bounded between 0 here and 3. So that's our a and our b, the lower limit and upper limit. And our f of x is this part, y is equal to the square root of x. So square root of x, we know that from our laws of exponents is same as x to the exponent of a half. So this can be written as x to the exponent of a half with respect to x, and our limits, we said, is 0 to 3. The values that we are given, which are bound this graph that we are given, or the curve that we are given. So from this part now, what you need is to integrate, then you substitute the limits, that is, you have the area for this particular region. So we know that from our integral, the area is going to be the integral of a half, x to the exponent of a half. We know that if you're integrating, we add 1, then we divide by the new exponent. So if we add 1, this is going to be 3 over 2, 1.5, that is 3 over 2. Then we divide by the new exponent, which is 3 over 2. So take note, guys, it's 1 divided by 3 over 2, which is 2 over 3. That's the inverse of 3 over 2. Remember, the inverse, 1 over simply means you invert these numbers. Or you can even just use your calculator there. All right. So this is what you're going to have from the integral. You're obtaining 2 over 3 x to the exponent of 3 over 2. Therefore, we've got our limits here from 0 to 3. So all you need is to substitute these values. Then you've got the area. That's it. That's your area, guys. So area is going to be 2 over 3. Our x at this moment is 3. That's to the exponent of 3 over 2. Whatever that we get, we subtract the lower limit when x is equal to 0. And as you can see, when x is equal to 0 here, there's nothing that we are going to have. But just for calculation sake, you can just indicate this part. All right, so this is what you're going to have. And from your calculator, we can simplify this. I just want you to simplify. You're going to obtain something like 3,464 square units. Okay. So the unit squared there is representing square units. So like I always say, you can even write it as square units like this, or unit squared. That is the indication of the area. So that is 5.12. That was to calculate the area from the integration that we're given. And on 5.2, evaluate the following. That is the integral of, we are given the limits, and that's 3 marks for that. Okay, so that's question 5.2. Let's see. You can just write this aside so that we can have our area properly. So from this integral, we are given that evaluate, that is, you are given the limits and so forth. So you can just even write this aside. Let's see what we can do to simplify this. So this is question 5.2. So you're given the integral of x2 minus square root of x, actually. So it's 2 minus the square root of, but I talked about the square root of x, guys, is same as x to the exponent of a half. So this one, I'm just going to write it as square root of x, which is x to the exponent of a half. And we are given the limits from 0 to 2. All right, so remembering that 2 is a constant. So if you're integrating a constant, all you need is to just multiply by x. Okay, so the integral of a constant, let's say it's a, with respect to x, is going to give us ax plus the constant of integration. So you just have to multiply it by x. So here it's 2, so which means the integral of 2 is going to give us 2x. Okay, minus, we move on to the integral of x to the exponent of a half, of which we worked out this one previously from that part that we had. We had x to the exponent of a half here, where we've got the square root of x. So we know this integral, guys. We got something like negative. It was x to the exponent of 3. So let me just write it down. It was 2 over 3, like this, x to the exponent of 3 over 2. Or even to write it as x to the exponent of 3 over 2 over 2, or it was 3 over 2, okay, if I'm not mistaken, from that part that we had. So you can even write it like this. It's not a problem, actually. Okay, so this is the integral that you're going to have. Then we've got our limits. So take note, guys, I did not repeat this part because we worked this x to the exponent of a half before. So the answer that we got is still same. Okay, so now we can apply the limits after integrating. Where x is equal, where we've got x, we are going to substitute first the upper limit, which is 2. So this is going to be 2 times 2 minus 2 over 3 into 2 to the exponent of 3 over 2. So that is for the upper limit. Minus for the lower limit, as you can see, in place of x, this is going to be 0 minus 0, which is just as 0 in this case. Okay, so simplify this from the bracket on your calculator. We must have something like 2.114. All right, so this is just an integral. It's not like we're going to write square units because we are not asked to calculate the area. Yes, we know that if you are integrating, you are actually calculating the area by substituting the upper limit and the lower limit. But in this case, it's just an integral. So there's no need for you to write square units for that one. Okay, so that was the integral. Okay, on 5.3, integrate the following, given this whole integral, and I've got 7 marks for us to integrate this. All right, so let's see what we're supposed to have in this case. So what I'm going to do is just rewrite these integrals in a way that we can be able to integrate this. All right, so first part, we've got the integral of 3x squared. Okay, so this is 3x in brackets. So remember from your laws of exponents, if you are given let's just say this is xy to the exponent of n. This is going to be x to the exponent of n, y to the exponent of n. So the exponent affects everything inside the bracket. So it's 3 to the exponent of 2, which is 9x squared. So take note, we are just rewriting this. We are not integrating for now. We are just rewriting everything in a way that we can be able to integrate. Okay, we've got 3 over the square root of x to the exponent of 3. Okay, so that's 3 over the square root of x to the exponent of 3. So let's work with this part first. From what made us to write this as the square, we know that the square root is to the exponent of a half. So this is going to be x to the exponent of 3 to the exponent of a half, which is going to give us x to the exponent of 3 over 2. 3 times a half, these two multiply, that's 3 over 2. So it was actually supposed to be 3 over x to the exponent of 3 over 2. But remember, this is 3 over, as long x is in the denominator, for you to write this in the numerator like this, you introduce a negative. So it is going to be 3x to the exponent of minus 3 over 2. Okay, so this is what you're going to have from this part. So, but take note, already there was a negative which was there. So it's going to be negative 3x to the exponent of minus 3 over 2. Okay, the other part, there's nothing that we can do here. We just have to rewrite as it is. So this part we're just going to take as it is. Okay, so that was it for this one. It's going to be 3 by 7 to the exponent of negative 3x. Okay, tan again. Okay, for tan here, this was actually an error. This part here, we can't find the integral of tan 4 over x. If it was the integral of tan 4x, yes, that one you can find it even in your formula sheet. We have got that part in our formula sheet. So that means we can actually calculate that integral. But for this one, if it is 4 over x like this, we can't determine this integral. So this was actually impossible for you to have the integral. Okay, so let me just show you what you have in your formula sheet. Maybe we can just agree on this one. We have got the integrals that we are given. Okay, let's just do it like this. Okay, if it is tan x, x as long it's like this, it's like not 1 over x. If it is 1 over x, that one totally you can't find its integral. Okay, this is x, but there it's 4 over x. It's something like 4 over x. So you can't determine that that integral for 4 over x. Okay, so what are you going to do if it is a condition like that? There's nothing that you're going to integrate. You do not integrate such typical questions, so you just have to leave that part like that. Okay, so that's it on question on this tan that we are given. So like I said, this one is actually an error. This one, if you got an answer there, it means everything is wrong. Okay, let's move on to the other part. Here we said we can't integrate this, so you're going to move on to this one. Minus 3 over cot x cos of x. If you are to check here, cot, if you are given 1 over cot, gives us tan. 1 over cos, it's sec. So this is going to be 3 tan of x sec of x. All right, so this we can simplify. Then we've got a negative 1 like that. Okay, with respect to x. So that's what you're going to have at the end. All right, so like I said, this part is actually an error. If you've got any other method that you have in mathematics, yeah, I'll be glad to know that method that you used to integrate this one, I'll be very, very glad for that. All right, anyways, let us integrate, guys. We've got 9x to the exponent of 2. Remember your integral, you add 1, then you divide by the new exponent. So it was supposed to be 9x to the exponent of 3 over 3. But as you can see, this can divide 9 divided by 3, that is 3. So you're going to have 3x to the exponent of 3. Okay, so that's what you're going to have. On the other part, we do the same again. Here we're supposed to multiply. We're supposed to add our 1 here. So if we add, it's negative 3 over 2 plus 1. Okay, let me just show the whole screen here so that we can be able to see on the calculator. So this is what we have here. It's negative 3 over 2. So that's negative 3 over 2. Whatever that we obtain here, we add a 1, which is negative a half. So it was supposed to be like this, guys. It was supposed to be negative 3x to the exponent of a negative half that we got. Then we divide by the new exponent, which is a negative half. So as we can see, these two, they are actually dividing each other here. So it's negative 3 divided by a negative half, which is a positive 6. Or you can even use your calculator. Negative 3 divided by a negative half, which is negative 1 over 2. That is positive 6. So this is going to give us 6x to the exponent of a negative half. And remember what I told you, to the exponent of a negative means 1 over. So it is going to be 6 by 1 over x to the exponent of a half, which is 6 over the square root of x. All right, so in this case, we are going to obtain positive 6 over the square root of x. So that's what you're going to have from this integral. We move on to the other part here, which is 3 by 7 to the exponent of negative 3x. So what I need you to know is that if you are given the integral of k, then we've got, let's just write in a way that we can remember anytime that we are going to work with these integrals. Okay, so let's say I've got k a to the exponent of f of x like this. Let's write it as f of x with respect to x. The integral of such a function is going to remain as k a to the exponent of f of x. Then over here, it is going to be the first derivative with respect to x times the ln of a, where a is the base. So if we are to use this concept here, this is our k here, this is our a, and this is your f of x. So in the numerator, is going to remain as it is, ka to the exponent as it is, which is 3 by 7 to the exponent of negative 3x. Everything over the first derivative with respect to x, which is, we've got negative 3x. So the derivative of negative 3x, take note, this is the derivative. So it is going to give us negative 3, then times ln a, which is the base. Our base here is 7. So it's going to be ln of 7. So as you can see, guys, these two can cancel, and we're going to have negative on top. So this is going to be negative 7 to the exponent of negative 3x, everything over ln 7. So the other part is going to cancel there. Okay, so that's what we had for this integral. Then we move on to negative 3 tan of x sec x. Okay, if you do not know this integral direct, therefore, back to the formula sheet, but you are not given these integrals because on the, as you can see on this integral, you just have sine, cos, tan. So what do? You go back to the derivatives. Remember, guys, I told you that integration is actually a reverse of differentiation. So what you're going to check is, what you're going to do is to check a part that is going to give us this part that we had of cos for tan and sec at the same time, because here is tan and sec. Okay, so from these integrals that we have from this derivative, let's check the one that gave us tan and sec. This is sec tan, which is same as tan sec. It's from the derivative of sec. So remember, if you differentiate sec, you obtain sec tan. And integration is the reverse. So if you integrate sec x tan x, your answer is going to be sec x. That's the reverse. So that means if we integrate that whole part, our answer is going to be a sec. All right, but already there's a negative which is there. We just have to write that negative as it is. So it's negative 3 but remember we said this is sec x. Okay, minus 1, which is with respect to x, it's a constant, so you just have to multiply with x, so it's negative x. Okay, plus the constant of it. Don't forget the constant of integration. That is the most important part that they are actually looking for in this question, the constant of integration. So it's very, very important to have it on your question. Do not neglect that. All right, so that's our integral. The constant is very, very important on your answer then. The last part, which is on question 5.4, we are asked to simplify. It's another integral again. So let's just take this side, even just integrate it here, but just 3 marks for this integral. Okay, so remember guys, this is cos, and we know that the integral of cos is a sine. But take note, if there is a constant term like this one, if there is a coefficient multiplying its y here. So if you integrate, it is going to give us sine of 2y, then you divide by that constant, which is the coefficient of y. Okay. And for sine, it's a negative cos. So that is going to be negative cos 2y over 2 plus the constant of integration. So don't forget to divide by 2, and also don't forget the constant of integration. So that was it, 3 marks for this, and that is 20 marks the whole of the question on integration. So as you can see, guys, it's actually very, very important for you to work with different question papers and revisions as you are preparing yourselves for the exams which are ahead of time. You can revise as much questions as you can so that you prepare yourselves for these exams. So that's what you had, guys, for Maths on African Motives. Till we meet again.